Good morning, girls. How are you? I hope you are all doing fine and well. Okay, today, just to wrap up lesson 18.3 about the corresponding figures are congruent, I'm going to solve with you the questions that I left for you, beginning by number 4 and 5 in page 911. Okay, in page 911, he told you that these two triangles were congruent, as we said. STU is congruent to VWX, and he wants to find the measure or the length of SU. Coming here, SU is congruent to VX. So just I'm going to see here, VX is equal to 43 feet, so SU is equal to VX equal to 43 feet. And please do not forget the unit. For measure angle S, according to congruency, measure angle S should be equal to measure angle V, right? What is the value of V? It's a 38, so 38 degree. And please do not forget the degree thing. Okay, and then I left for you as well these two questions, question 6 and question 7, in which you are going to be doing equations. He is telling you that these two quadrilaterals are equal. And then he wants to find the measure of the length of LM. From the congruency, LM is congruent to GH, and GH is equal to 40x plus 3 centimeter. Take care, do not miss or do not mix 4x plus 3 with 9y plus 17. Take care that the thing with the 4x is written beside its centimeter. So this is a length, while 9y plus 17, there is a degree up here. So this is an angle measure. Do not mix them together. So anyway, since that LM is equal to GH, we can say that 6x minus 3, because this is LM, is equal to 4x plus 3. And then I have an equation. What should I do? I should solve it to find x. And this is what we did. 4x plus 3 is equal to 6x minus 13. He solved it here right away, but I think it's very easy. How can I solve this kind of an equation? Combining like terms. I'm going to put x together and the numbers together. So shifting. Just shift 6x here with a negative sign and shift 3 here with a negative sign. And then combine like terms until you will find x. So x here was equal to an 8. X was equal to an 8. After you find x, because a lot of girls just gave me x and that's it. No, actually you will lose mark here. He didn't tell you to find x. He told you to find what? LM. So just finding x is not the answer. X is a part of LM. To find LM, I'm going to see LM is equal to 6x minus 13. So I have to substitute then. 6 multiply 8 minus 13 should be equal to 35 centimeter. This is how I can find LM. So please do not forget the substitution step. Finding measure angle H, I'm going to see in the congruency. H should be equal to M. Where is H here? Yeah, H is here. Yes, 9y plus 17 is equal to measure angle. We said M. Where is M here? Yes, 11y minus 1. So again, I'm creating an equation. 9y plus 17 is equal to 11y minus 1. Do shifting. Shift y in here and shift the number in there. And then you will find the value of y. Y was equal to a 9. Since I found y, I can find measure angle H. Please do not stop at y. You have to substitute. Substituting 9 multiply 9 plus 17, and just I substituted 9 for y. It's equal to a 98 degree. And do not forget the units, centimeter for here and the degree in here. And then I left for you this thing that we said about the proof. I know that some of you are struggling with proof, but I told you this is not the end of the proof. We are taking it for the whole next module. So you will practice a lot in it, so don't worry. Okay, anyway. I left for you question B yesterday, or we did it? I think we did it, right? I think we did it. So let's check question 8. Given that triangle SVT, where is SVT? SVT the one up here, is congruent to triangle SWT. Prove that ST bisect angle VSW. What does the word bisect mean? We said before, bisect, we said before that it divides the angle into, or divide anything into two equal parts. This is bisect. So he is telling you, try to prove that ST, this line in here, bisect this great angle, this big angle, into two equal parts, which mean I need to prove that angle VST, the angle up here, is equal to angle TSW. If I prove that they are equal, so I can say that ST actually bisect this big angle. Now, are they equal? Let's check from here. Here he is telling you that triangle SVT is congruent to triangle SWT. And we can say that angle T is congruent to angle T. I mean that this up angle is congruent to this angle. Angle V is congruent to angle W, which means this angle is congruent to this angle. And angle S is congruent to angle S. What does this mean? It is the same angle. No, he means in here that this angle up here, which is the one we are talking about, VST, is congruent to the second S, which is down there, which is TSW. Now, this is the thing I am required to prove. So as we said before, you are going to do a table. A lot of girls did the statements just by writing without the table. No, this is wrong. You have to please write, draw a table for yourself. As we said, with two columns, statements and reasons. And the first statement you should write is everything given. So since this is the given thing, so I'm going to write triangle SVT is congruent to triangle SWT, and why? Because this is given. And then I'm going to tell him what the thing we discovered. Since these are congruent, so I can say that the up angle, which is called VST, is congruent to triangle TSW. And that's why, because corresponding parts of congruent figures are congruent. Corresponding parts of congruent figures are congruent, right? And then the last thing, since I discovered that these two angles are equal, I can say that ST bisects angle VSW, and this is why, because this is the definition of angle bisect. Because this is the definition of angle bisect. Okay, let's think about question 9 as well. In question 9, we have two quads, they are congruent. And then you are given another given, which is that AD is equal to CD. In here, AD is congruent to CD. I'm required to prove that AD is congruent to GH. Let's see. In here, since these two quads are congruent, GH is congruent to what? To CD. And CD is equal to what? To AD. You remember the transitive property of yesterday when we said X is equal to Y, and Y is equal to 2, so X is equal to 2. The same thing is happening here. GH is equal to CD, and CD is equal to AD, so AD is equal to GH. Transitive property, right? So again, doing a table with statements and reasons. The first statement, the first two statements actually is the givens that I have, like in here, that the two quads are congruent, given, and that AD is congruent to CD. And then I discovered, due to congruency, that CD is congruent to GH. And that's why, because corresponding parts of congruent figures are congruent, the name of the lesson. Since they are equally, but I can say using these two statements that AD is congruent to GH, because this is the transitive property of congruency. Right? Okay? Okay. Okay. We will take some more questions about lesson 18.3. In page 918, we are going to be solving question 21 and question 23. Let's see what about 21. A company installs triangular pools at hotels. All of the pools are congruent, and triangle JKL is congruent to triangle MNP. what is the parameter of each pool? And he is telling you that all of the pools are congruent. So if you get the parameter of one pool, this is the parameter of all pools. What are parameter? What is the parameter? We said before, parameter means that I add all sides together. Adding all sides together. Since you are talking about a triangle, I have how many sides? We have 3. So I have to add all of the 3 triangles together. The problem, all of the 3 sides together. The problem is JL is known, it's 41 feet. But KL is unknown. It's a 5x plus 1 feet. JK again is unknown, it's a 4x minus 4 feet. And what about the 20x minus 15? What is this? This is angle K. As you can see, he is giving you like an arrow. This is angle K. This is not a side. Do not mix sides with angles. Angles, you will have a degree in here. For sides, you will be having feet, centimeter, inch, whatever. So how can I solve this so that I can find the parameter? Using congruency, can't you see that from here? Measure angle K is congruent to angle N, right? And 15x plus 15 is actually equal to 20x minus 15, right? Here I will be having an equation in which I can solve, right? Okay, let's see this. Okay, I want to make it bigger. Okay, let's see what are we doing in here? Yes, from here. So as we said that angle K is congruent to angle N, right? So I can say that 20x minus 15 is equal to 15x plus 15. We said when I have an equation like this, just I'm going to do a simple shift to put x together and the numbers together. So I will end with 20x minus 15x, because this was positive, it will be shifted with a negative sign, and the negative 15 will go here with a positive sign. So 15 plus 15. 20x minus 15 is actually 5x. Divide by 5, so 30 divided by 5, so I found that x is equal to a 6. We found x, but take care, the question was not about finding x, it was about finding what? The parameter. And parameter, I mean, I need to find this, it's already known, but I need to find the 5x plus 1. I need to find the 20x minus 15 and the 4x minus 4, right? Now, beginning by JK. JK is 4x minus 4. Substituting, I'm going to remove the x and put 6. So it's a 4x. It's a 4 multiply 6. Sorry, minus 4. It's equal to 20 feet. Right? Okay. What about JL? JL is already known. It's a 41 feet. What about KL? From the drawing, KL is equal to 5x plus 1. So just substituting. So 5 multiply 6 plus 1, it's again a 31 feet. And then what should I do with the 3? Add them all together. So 20 plus 41 plus 31, your answer will be a 92 feet. So the parameter is 92 feet. Okay? Understood? Okay. Going to the second question. Question 23. In question 23, you have 2 triangles and you have some statements that it's required from you to tell me is it true or false. And these are our 2 triangles. Triangle MNP is congruent to triangle QRS. Okay? Let's begin with the first question. Okay. In here, I have the 2 triangles as drawn for you in here, and the first statement is triangle QRS is isosceles. What is isosceles triangle? Isosceles triangle, as you know that any triangle have 3 sides. When two sides are equal, this is called an isosceles triangle. In triangle QRS, this is 52 and this is 34. So till now, it's not an isosceles. But what about QR? Let's find out. QR is congruent to MN, right? And MN is 52. So QR is 52. So I can see that my triangle now is having two sides equal to each other. So is this an isosceles triangle? Yes. So this is true. Statement number 2. MP is longer than MN. Let's find out. MP, this thing here. MP is equal to QS, right? And QS is 52. So actually, MP is 52 and MN is 52. So is MP longer than MN? Actually, no, they are equal. So this is false. Question C. Measure angle P is equal to 52 degrees. Measure angle P is 2x minus 33. So I have to find x, right? Now, from congruency, angle P is equal to angle S, which means that 2x minus 33 is equal to x plus 19. Having an equation, let's solve the equation. 2x minus 33 equal x plus 19. Shifting, if a 2x minus x is equal to positive 33, x was positive, it will be negative, 33 was negative, it will come as a positive. Finding x is 52 degrees. Am I done? You are not done. You have to find measure angle P, so I have to substitute in x. So 2x minus 33 is going to be 2 multiply 52 minus 33. It's a 71 degree. So is measure angle P equal to 52? It's a false statement. Then question D. The perimeter of triangle QRS is equal to 120 millimeter. The perimeter of triangle QRS is equal to 120 millimeter. Let's go to find out. QRS, this is 52, this is 34, and we just found out that QR as well is 52. Perimeter mean I have to add all of these together. Let's add all of these together. 52 plus 52 plus 34. It's 138. Is this true? Again, it's a false statement. Okay, for the last question, which is question E, measure angle M is congruent to angle Q. Angle M is congruent to angle Q. Let's find out from the congruency. M is actually congruent to angle Q. But this, of course, is a true statement. True statement. Okay? Okay. We are done with this lesson and we are done with all module 18. So for now, you will be having some homework about this lesson, and we need to go now for the revision pages of module 18. Okay, now we are in page 922. We are in page 922. I'm going to leave question 1 and 3 and 4 for you, and I'm solving 2 with you. In question 2, find the rigid motion to transform one figure into its congruent figure. And he is telling me that triangle ABC is congruent to triangle DEF. Since they are congruent, it means that there is a sequence of rigid motion that can transform this figure into this figure. And a sequence, I mean that one of the 3 things is happening, or not one, a sequence of the 3 things is happening: rotation, translation, and reflection. Let's find out how can I think about ABC transforming into DEF. It's very, very, very obvious that here we had a horizontal line that suddenly changed into a vertical line. My triangle was originally horizontal, and then it moved in this direction to become vertical. What can change something horizontal into something vertical? And remember that the degree between the horizontal and the vertical is a 90 degree. So actually this is like the ceiling fan example that we were talking about. This is actually a rotation. So it's very obvious that a rotation happened here, right? There is a rotation happened here. In which direction? We said before, when you tell me rotation happened, you have to tell me the degree and you have to tell me in which direction. So here, in which direction? I am moving in this direction, and this direction is counterclockwise. And how many degrees? How many quads did you move? I only moved 1 quad. 1 equal to 90 degree. So 90-degree rotation happened, right? Counterclockwise. And let's see the full example in here. The full solution. Okay. In here, I'm saying for myself that I understand that a rotation happened. But in most of the times, rotation will not be enough. There will be a translation. Just to make sure, let's trace a point. Since that triangle ABC is congruent to triangle DEF, so point A should be equal to D. And they should have the same coordinates after the translation, right? So let's start with point A. Point A started with the coordinates of 2 and 4. Since we said a 90-degree counterclockwise happened, I know that 90-degree counterclockwise means that x and y is going to be negative y and x. Let's perform this transformation in here. Flip and put a negative for y. So it's going to be negative 4 and 2. But point D, if you go back to the paper, if you go back to the figure, point D is actually negative 6 and 4. Negative 6 and 4. Negative 6 is far left from point A by 2 points. I mean that A, to move from negative 4 to become negative 6, it should move left 2 units, right? What about A is 2, it needs to become a 4. It needs to go up. How many units? Again 2 units. Going left means x minus, going up means y plus. So my translation is going to be x and y equal to x minus 2 and y plus 2. So this is what happened. I had a rotation counterclockwise 90 degree. So the first thing is x and y will be negative y and x. Then translation happened by x minus 2 and y plus 2. Did you see how did I solve it? To solve something like this, you have to trace a point, like we did here. I traced a certain point. I told myself point A should be point D. So I have to trace point A step by step until I make the coordinates the same as D. Okay? Okay, very well. Going back to the revision papers. So for page 922, as I said, you are going to be doing number 1. And of course, number 2, you have to write the answers. And number 3 and number 4. And for the next page, you have to do question 1 and question 3. You have to do question 1 and question 3 as well. Okay? And by this, module 18 will be finished, and we are starting in module 19 now in a very, very small part. Okay. Unit 8, which I think, inshallah, will be the last unit to take. I don't think even that you are going to be taking all of these modules. And even in these modules, not all lessons will be taken. So don't worry. Unit 8 is called lines, angles, and triangles. This is the core of geometry. And this is very, very important, girls, that even if we didn't have the time to finish all of this, I think it's very crucial and important for you to try to finish it by yourself. It's very, very important. Lines, angles, and triangles. And we are going to be starting with module 19, which is called lines and angles. But before we start, we have to do some vocab thing in page 930. Page 930. Okay. Visualize vocabulary. Angle relationships. We have 3 kinds of angle relationships. Okay, coming from here. As you can see, we have something called adjacent angles. We have something called vertical angles. And we have something called complementary angles, and we can even add another circle for the supplementary angles. And let's understand what is all of these. Okay, you are going to be writing each one of these in here, and then please add another circle for the supplementary angle, and we are going to draw the shape of the angles in here. Okay, let's take them. What are those? Okay, let's begin with the adjacent angle. Number one, the adjacent angle. Adjacent mean, in English, adjacent means what? Adjacent means beside each other. But adjacent angles mean two angles beside each other. When you have two angles beside each other, those are called adjacent. They can be any angle. They can be any degree, 90, 60, 70, 40, 20. This is not my problem. Since they are beside each other, they are called adjacent. Yani for example, it's going to be something like this. These two angles together, you know, we have two angles in here. The first angle is this one here, and the second angle is the one in there. These two angles together are called adjacent angles. Okay, okay. Let's take number two. Number two is called vertically opposite angle, or just simple vertical angles. What is vertical angles? Vertical angles is when you have two angles that are facing each other, just like the scissors or the X. Whenever you hear the word vertical angles, always remember the X. Yeah, I mean like this. Can you see these two angles in front of each other? They are like forming an X. These two angles together are called vertical angles. Even these two angles together are called vertical angles. Whenever you have the letter X and two angles are in front of each other, they are called vertical angles. And as we will be taking, inshallah, in this module, they are always equal. If this increase, this is increasing. If it's decreasing, it's decreasing. They are always equal. If this is 20, it's 20, 30, 30, and so on. Okay, for number 3, complementary angles. I think that we took this before. Complementary, we took actually all of this before. Complementary angles mean when you have two angles that form a 90 degree. When you have two angles together that form a 90 degree. Yani in a way, it will be like this, for example. As you can see, this angle is exactly 90 degree. This angle is 90 degree. These two angles together are called complementary angles. These two angles together are called complementary angles because if I add them together, they will be 90 degree. Yani if this is 30, this should be a 60. So the opposite, I think. If this is 30, this should be a 60 because 60 plus 30 is 90. If this was 70, so this should be a 20, and so on. The main important thing is that whenever you add them together, it will be a 90 degree complementary angles. For the fourth one, it's called supplementary angle or angles. Supplementary angles are two angles that if you add them together, it will be 180 degree, as if they are forming a straight line. You know that the angle of a straight line is 180, right? When I have like a straight line like this, sorry. When we have a straight line like this, what is the angle? And if I try to measure the angle from the beginning of the straight line till the end of the straight line, it's like a complete protractor. So actually the angle is 180 degrees. If we have two angles in here, like this, for example, can you see these two angles? We have a one obtuse angle, big angle, and one smaller acute angle. These two angles together, if I add them, it will be 180 degrees, right? So this is called supplementary angles. Supplementary angles is when you have two angles together, you add them, it will give you a 180 degrees. So this is called supplementary angles. Okay, very good. Going back to our book. So in here, we drew or we wrote the name of the angles and we drew them. And then, okay, a or an what has three sides with the same length? From here, a what? This is what? An equilateral triangle. The equilateral triangle is the triangle that have three sides equal to each other. So here, equilateral triangle. A circle is what in a polygon if each side of the polygon is tangent to the circle? Actually, I don't think you took this before, but I'm going to tell you that it is a circle is inscribed. What is this? When you have any shape like a square, for example, if we try to draw this, for example, if you have if we have a square, for example, like in here, and you try to draw a circle completely inside, don't mind my drawing, okay? This circle is exactly inside the square, right? It's all inside the square. So all of the four sides are touching the circle, right? In this case, this circle is called an inscribed circle. And we are going to take this in details, don't worry. But for now, just understand that a circle, when is touching the four sides of any figure, square, rectangle, polygon, quadrilateral, anything, it's called an inscribed circle. It's called an inscribed circle. So just in here, so just write in here, an inscribed circle. A circle is inscribed. The what of a right angle triangle is the longest side of a triangle. You remember the right angle triangle? What was the longest side which is opposite to the 90 degree? It's called the hypotenuse. So in number 3, write hypotenuse. It's in here, hypotenuse. Okay? Okay, so this was in page 930. We were in page 930. Okay, going to page 932. The page of the Are You Ready for Module 19? Page 932. Angle relationships. You remember what was the angle relationships? I hope. We will see. Let's begin by number 1. The measure of angle BFE, let's go to find. Where is BFE? BFE. All of this angle is 110. Find measure angle EFD. Actually, we just explained it. The measure of angle BFE, well, this one and this one, they form a what? They form a straight line. This is the supplementary angle. Yani if I add this to this, it should be 180, right? Since this is only 110, so how can I find EFD? 110 plus x is equal to 180. So to find x, I'm just going to shift 110. So actually 180 minus 110, I will find the angle. It should be 70 degrees. So measure angle EFD is 70 degrees. Yani what I wrote is exactly like this. What we wrote for number 1, page 932, number 1, we wrote that 110 plus x is equal to 180 degree. So x is equal to 180 minus 110 equal 70 degree. So we found the measure of the angle, okay? Okay, going to again to our book. Question 2. The measure of angle BFE again is 110. Find measure angle BFC. BFC. Can't you see the giant X that we have? Giant X, can you see? These two angles are opposite to each other. Since they are opposite, so they are what? Vertical opposite angle. And vertical opposite angle are equal. So this angle is equal to this angle. Angle EFD, or this angle, we just found it. It was 70 degree, right? So the up angle should be 70 degree as well. So here just we are going to write 70 degree. Okay. Parallel lines cut by a transversal. Do you remember the name of the angles that we had when you have a transversal cutting two parallel lines? We had 4 types of angles, if you remember. The first angle was same side interior angle, like angle 4 and 5, angle 3 and 6. They are called same side interior angles. And the same side interior angles, when you add them together, it should give you 180 degrees. This was the first kind. And then what about angle 1 and angle 1, 3, 6, 8? They are vertically opposite angle, the X. What about angle 2 and 6? The letter F. You remember the letter F? This was corresponding angles. Yes, this was called corresponding angles. When you have the letter F, like 2 and 6, like 3 and 7, like 1 and 5, like 4 and 8. Those are called corresponding angles, and corresponding angles are always equal. They are always equal. And then, do you remember what about 4 and 6? 4 and 6 with 3 and 5? They were called alternate interior angles. Alternate interior angles. Angle 3 and 5, angle 4 and 6. Alternate interior angles. And alternate interior angles are always equal again. And then we have something called alternate exterior angles, like angle 1 and angle 7, like angle 2 and angle 8. And for alternate exterior, again, they are always what? They are always equal. Like 1 and 7, like 2 and 8. Okay, based on this, since that measure angle 3 is 110, find measure angle 1. Very easy. Those two angles together are vertically opposite angle. There is an X letter here. So measure angle 1 is 110. Okay, measure angle 3 is 110. Find measure angle 6. 3 and 6 together are inside and they are on the same side. So they are called same side interior angle. And same side interior angle are 180. يعني when I add them they should be 180. يعني we are going to write here that measure angle 3 plus measure angle 6 is equal to 180, right? Since that angle 3 is 110, 110 plus the unknown, which is measure angle 6, is equal to 180. So what should I do? I will shift the 110 in here to find measure angle 6. So measure angle 6 will be 180 minus 110 equal to a 70 degree. Okay? Okay. Going back to our book. We finished number 3, 4, number 1 and 2. We are left with number 5 and 6. Okay, for number 5 and 6, actually, I will leave them until we take their lesson because this lesson was not taken before about the perpendicular line and parallel line. So it's better to leave them until we took the lesson, until we take the lesson, inshallah. Okay. Okay. This is the enough for today. From tomorrow, we are going to be starting in lesson 19.1. And for today, you have to do some of the homework that are is going to be posted in on Class Dojo. Thank you very, very much.